Let's go ahead and take a look at division of fractions. And what is difficult about division of fractions, the concept is it's related to the idea that we don't have a lot of concrete models, something to show students around division of fractions. So when I say 1/2 divided by 1/6, it's hard to kind of imagine what that looks like. So to start, let's think about 12 divided by 3, right? Why is 12 divided by 3 equal to 4? And so we have different ways to think about it. Set model here, 12 counters and put 3 into each group. How many groups, right, can we have? And so you could see it. There are 4 groups of 3. But back to this question of 1/2 divided by 1/6. When we're thinking about how many 3's go into 12, we can think about it the same way. How many 1/6 go into 1/2? Again, here's a concrete model here. Fractions are not always this clean or clear cut, right? Or benchmark fractions. But I can see 1/2 divided by 1/6 is 3 because we could see there's 3 of these 1/6 go into 1/2. So there's a concrete model. Let's take a look at these two here. 1/4 divided by 1/8. Again, I'm avoiding any rules, what you may have learned in the past. 1/4 divided by 1/8. And so we could see here's our 1/4. And so now I'm looking at this piece here, and how many 1/8 go into there? There's 2 of them. So the answer to 1/4 divided by 1/8 is 2. You could see it. There it is. How about 2 divided by 1/4? Well, there's 2. And then we just count how many 1/4s, right? How many 1/4s are inside of the 2? And there are 8 1/4s. So there's 8 fourths. Or that becomes, sorry, that's not right. How many of them? There are 8 of them. So that's the answer. 8 1/4s. The answer is 8. 8. So again, fraction tiles can be used to model that for us as we get there. And so we're going to show rules. Obviously, all this leads us to a rule for fraction division, which is A over B divided by C over D equals A over B times D over C. So when we see that, if we use it real quick and turn it into that reciprocal rule, then you see you get your answers there. 2 over 1 times 4 over 1, right? So these visual or concrete models motivate us to come up with some rule for fraction division, which there it is. So looking at this example here, 6.37, divide and write the answer in simplified form. Again, the rule would be to flip the second one, multiply across, and then you could see I get 7 times 27 over 18 times 14. But notice I put it in simplified form before multiplying, and so then you're going to see that we'll have this 9 and this 9 would be divided to 1, become a 1. 7 divided by 7, or 7 over 7 is 1. So you're just left with 3/4. So this is what leads us to what we call the invert in multiply, kind of this concept, and that's the procedure that is often taught to students. But this leads us to, you've been in this class long enough or gone through the book or long enough to realize there has to be other ways to think about it, and there are. So let's go ahead and take a look at one of the ways is through a common denominator method, right? Solve each of these problems here. Well, if you use your rules, you will see right away, like I did a few of them, 6/4 divided by 3/4. You see you flip the 3/4 and your answer is 2, right? You get 6/4 times 4/3, right? Because you flip the 3/4, you get 4s would divide. You get 6 over 3, which is 2. I did another one, the 6/10 times 3/10. Flip the 3/10 to 10/3. The 10s will divide out. You get 6 over 3, or 2. What this leads, take a look in red. What this leads is actually when we have common denominators, we do not need the invert and multiply rule when we have common denominators. Notice what the rule we could do here. When you have common denominators, just divide A and B. So that's where you will see I could just do 6 divided by 3 is 2. There's my answer. 6 divided by 3 is 2. 5 divided by 2 is 5/2. There's our answer. So if I want to do this one here, since it's common denominator, the answer to that is just 8 divided by 4, or 2. So that's 2. This one, 2. The answer for this one would be 3. Just do 6 divided by 2. That's the rule when it's common denominator. That should make sense because we have the same number of unit fractions, right? We have the same unit fraction. That's what we're dealing with. So take a look at that as you try your own.